All right, let's do this review video for 7.1, 7.2. All two people in here. So, find the degree of each of the following monomials. So, number one, the degree is going to be 9. You just figure out the degree of the exponents, add up all the exponents for the variables, I mean. For number 2, we have a 5 and a 1 for that y, so the degree is 6. For number 3, the degree is going to be 0, because you don't have a variable, so it's a degree of 0. 4, you add up 7, 5, and 11, that's 23, right? Yeah. And those are your answers for the degrees of each monomial. For number 5, we're going to find the sum, so we're just going to add like terms. So what I can do is I can figure out what the highest degree of the whole thing is. That's x to the 4th. And I kind of start from x to the 4th and work my way down. So x to the 4th, I don't have any other x to the 4ths here. So x to the 4th. After that, it's going to be the 3rd degree. I have a negative 3x cubed here and x cubed here. So negative 2x cubed. Then after that should be a square. I have a negative 2x squared right there. Then I have 7x here. And then negative 10 and 14 gives me a positive 4. And the reason I do it that way is so I can have my final answer in standard form as well. And that's your answer. What's up, Andrew? All right. Number 6, find the difference. So I want to find g of x minus f of x here. So g of x minus f of x. So all I'm going to do is just rewrite f of x as a negative. So it's going to be negative 2x to the 4th plus 3x cubed plus 5x squared minus 2. So basically what I'm doing is I'm changing g of x minus f of x into g of x plus negative f of x. So then from there, it just becomes a addition problem. You just add like terms. So same thing, I'll start with the highest degree. That's 3x to the 5th. That goes first. I don't have anything else to add to it. After that's the 4th degree. That's negative 2x to the 4th right here. After that will be the 3rd, so 4x cubed and 3x cubed right there. That's 7x cubed. Then go to the square. I have negative 7x squared and positive 5x squared. That's negative 2x squared. Then 2x is a 2x. Then negative 9 and negative 2 is negative 11. So really subtraction problems, I just distribute the negative and add like terms to make it easier. Number 11, this one's going to be a little harder. So the perimeter of a parallelogram is 34 inches with adjacent sides measuring x squared minus 2x minus 3 inches and 2x squared plus x plus 6 inches. Find the height of the parallelogram if the height is perpendicular to the longest side and the area is 36 square inches. So parallelogram looks like this. So I need to figure out the height's going to be if the area is 36. So area of a parallelogram is your base times height. I don't know which one of those is the base, but I do know that the longest of the two will be the base. So to figure that out, I'm going to use the perimeter, which I know is 2 times your length plus width. So in this case, it'll be the perimeter is 2 times x squared minus 2x minus 3 plus 2x squared plus x plus 6. So in this case, x squared plus 2x is 3x squared. Negative 2x plus x is negative x. Negative 3 plus 6 is a positive 3. And I also know my perimeter is 34 inches. So I know that 34 is 2 times 3x squared minus x plus 3. Right, what I'm doing is I'm using the perimeter that I'm given to solve for x. So when I find my x, I can plug it back into each side to figure out which one's longer. So I divide the 2 over, I get 17 is 3x squared minus x plus 3. Subtract the 17 over 3x squared minus x minus 14. So you can solve this out now by either by factoring the quadratic formula, whatever you want, it doesn't matter. But if you factor it, I think what you end up getting is 3x minus 7 and x plus 2. Yeah, so you get 3x minus 7, x plus 2. And that all equals 0. So that tells me x is 7 over 3 or negative 2. So just because I have an x value of negative 2 doesn't mean it's not possible, because x's can be negative. What can't be negative are your sides. So what I'm going to do is take both these x's and plug them back into my two sides that we had from the beginning, right? The 2x squared plus x plus 6 and the x squared minus 2x minus 3. I'll plug in both of those into that variable and in those sides. And if one equals negative, that means I know it can't work. They both could work, but we wouldn't do that to or equals. So only one is going to work. So plug them in, see which one it is. So if I plug in 7 over 3 into x squared minus 2x minus 3, what I get is 7 over 3 squared minus 2 times 7 over 3 minus 3, or 49 over 9 minus 14 over 3 minus 3, which is the same as 27 over 9. So 49 over 9 minus, is that 42 over 9? What you end up getting, 7 over 9 minus 27 over 9. So I'm just doing a lot of arithmetic here to show that 7 over 3 is not going to work, because when you plug in 7 over 3, you get a negative distance for a side. So 7 over 3 is not going to work. And if you plug in negative 2, I'm not going to show the work for that. When you plug in negative 2 into either side, you get positive numbers. So that's what ends up working. All right, so I'm going to erase all this. You don't need this anymore. And actually, I lied. I am going to put in a negative 2 to need to solve this problem. So you plug in negative 2 into the first formula. You have negative 2 squared minus 2 times negative 2 minus 3. You solve that out. That becomes 4 plus 4 minus 3, which is 5. So I know one side is 5, and the other one, we'll do that in blue right here. That's 2 times negative 2 squared minus 2 plus 6. That's 8 minus 2 plus 6, or 12. So my two sides are 12 and 5. So that tells me that this base right here is 12. This side is 5. And since I know that my area is 36, what I have is that my area is base times height, or 36 is my base of 12 times my height, or height is 30. And I know that 12 would be my base because I'm told that the height of the parallelogram is perpendicular to the longest side. So the longest side has to be what's perpendicular to it, and perpendicular means you make a right angle. Make sense? Pretty good. Now let's start on 7.2. Finally, we create the product of each of the following polynomials. So number 12 at 4x to the 6, y squared times negative 7x cubed, y to the 8. So really, when you're multiplying stuff out, you just add up all the polynomials. So here, it's just because it's parentheses doesn't mean you change that rule. It's still going to be 8 plus 3 plus 2 plus 6, which will give you 19. For number 13, same thing. Well, not really the same thing this time because it's two polynomials that are more than just one term. So the first polynomial, it's a x to the 5th minus 8x cubed plus 5x squared minus 3. The second one is x to the 7th plus 6x to the 4th minus 2x cubed minus 8x plus 7. So what I'm going to do is I'm going to figure out, well, what's the biggest term on the first polynomial and what's the biggest term on the second polynomial? And you can add the exponents there to figure out your degree of the polynomial. So in the first one, I have an x to the 5th, and the second one, I have an x to the 7th. So if you were to multiply this whole thing out, the biggest term you'll get is when you multiply x to the 5th with x to the 7th to give you x to the 12th power. And that's why the degree of this polynomial is 4. Make sense? We're good? For the leading coefficient of the following products, so we're going to kind of continue off that. The leading coefficient is the coefficient in front of the term with the highest degree. So if you have polynomials where you're kind of adding everything together, you're multiplying together, like we have in 13, 14, and 15, all you need to do is in each parentheses, find the term with the highest degree. So in 14, it'll be 6x to the 7th and 5x to the 9th. You multiply them together because if you were to distribute this whole thing out, you have the biggest term. You multiply 6x to the 7th with 5x to the 9th, which will give you 30x to the 16. So my leading coefficient is 30 for a degree of 16. And this will work if you have like multiple parentheses. If I had another parentheses here, I'll do it in green. That was like x cubed plus 17x squared, something like that. All you do is take this 30x16 you have, and you multiply with x to the third to give you 30x to the 19. So if I had a new problem, had this green part added to it, all you do is take the highest degree term in each polynomial, multiply them together, and that's going to be the degree of the whole overall polynomial. Make sense? Number 15, same thing. So I have negative 2x to the 9 and negative 8x to the 7th. Multiply them together to get 16x to the 16. So I have a degree of 16 with a leading coefficient of 16. That's 16. Good? Great. Now find the product of the following pairs. Okay. This one is really just the, what's it called? You can distribute it out or use the box method. So I'll show the box method again. So 3 by 2, x squared, negative 5x, 2x, and negative 3. Multiply in, you have 2x cubed, negative 10x squared, 4x, negative 3x squared, 15x, negative 6. Add like term to get 2x cubed, minus 13x squared, plus 19x, minus 6. So you can do it this way, you can just distribute it out if you want to, but all multiplication can be just like that.
It is now 3 o'clock. If you are not with a coach, director, sponsor, or a tutorial friendly teacher, you must now exit the building.
All right, last problem is that we need to verify its identity. So all you ever have to do is just kind of expand everything out. So on the left side, I'm going to expand that out, distribute the a squared in. You get a squared x squared plus a squared y squared, and do the same thing for the b squared, distribute that in. You get a positive b squared x squared plus b squared y squared. And this should all equal the right side, which we're going to expand out as well. So this ax minus by squared, that's a perfect square trinomial. So you can figure that out pretty quickly. It's going to end up being a squared x squared minus 2 ax by plus b squared y squared. And then the other part is bx plus ay all squared. When you do that, it's also a perfect square trinomial, so you can figure it out pretty quickly. It'll be b squared x squared plus 2 abxy plus a squared y squared. From here, we're going to add like terms on both sides. So on the left side, I have really nothing to add together, right? So it just stays as it is, a squared x squared plus a squared y squared plus b squared x squared plus b squared y squared. On the right side, all that really happens is that this ax by and abxy, the variables are in different orders, but it doesn't really matter. Since multiplication is commutative, it doesn't really matter what order you put it in. 2 times 3 is the same as 3 times 2. And ax by is the same thing as abxy. So they cancel out, what I'm trying to get to. And I'm left with this a squared x squared plus b squared y squared plus b squared x squared plus a squared y squared. So, like I said, I put it in the same order, but it's the same thing. A squared x squared, a squared x squared, a squared y squared, a squared y squared, b squared x squared, b squared x squared, b squared y squared, and b squared y squared. It's all the same. So that's what we can say, therefore it's true. Also, when you do these verified identities, one tip I'll give, I don't think many people will even try to do anyway, I want to say it anyway. Don't ever move anything over the equal sign, leave everything on both sides as it is. Don't move anything over, just work on the left side and the right side and expand everything out. If it equals each other, the polynomial identity is true. All right, well, that's it.